So hello everybody, we are dealing with the next problem in the Irodov series, and this one is problem number 1.179. This problem is technically a part of variable mass system and rocket problem which we are discussing. So this problem, before we start with this problem, if you have not watched 1.178 then kindly watch it, because we will start this problem using the equation MA equals F minus mu u, which we have already discussed while deducing problem 1.178. So based on this equation, we have this problem. The problem is stating a rocket moves in the absence of external forces by ejecting a steady jet with constant velocity u relative to the rocket. Find the velocity v of the rocket at the moment when its mass is equal to m, if at the initial moment it possesses the mass m0 and its velocity was equal to 0. Make use of the formula given in the foregoing problem. That is, the problem is itself is stating that we can use the problem with the formula which was already evolved in the equation in the problem 1.178. So we have this problem. Now the problem is stating there is no external force. So if there is no external force, then we can say that capital F equals 0, and we get the equation MA is equal to minus mu u. And the next equation which we can write from here is equal to m dv by dt is equal to minus mu u, and also we can write that mu is equal to minus dm by dt. So if we write mu as minus dm by dt, that is the rate at which the mass is ejected, then we can write this expression as dm by dt multiplied by u. So we will have this equation in this form, and now if we arrange the terms, then we can say dv is equal to u dm by m. So we'll get something like this, where u is the relative velocity of the ejected gas with respect to the rocket, relative to the motion of the rocket. And now if we integrate both sides, so at the moment when the mass was m0, the velocity is written as 0, and at a time when its mass becomes m, its velocity is v, which we are evaluating. So we can say v minus 0 is equal to u, and the integration is ln m by m0. So we can write this equation as v equals minus u ln m0 by m. That is, if we interchange this term, we get an equation like this. So this is the equation which we are looking for in this particular problem, and this was problem number 1.179, which is giving us the equation of velocity of the rocket whose mass is changing as it is moving in free space, where capital F is the external force which is missing in the problem, mu v is the thrust force. So in this present scenario, the rocket is moving solely under the influence of thrust force, where ma is equal to minus mu u, and then we solve this equation to get the velocity which is changing with mass m in terms of ln m0 by m.